Hi there, welcome to Science with Folly. Today we are looking at ionic compounds. Firstly, we have to figure out what an ion is before we get too much further. And remember, an ion is an atom that has lost or gained. What is it lost or gained? It lost or gained electrons. And by doing so, an ion ends up with a positive or a negative charge. Now, an ion that loses electrons ends up with more protons than electrons, and so therefore it has an overall positive charge. What do we call these things? We call a positive ion a cation ion. An atom that gains electrons has more electrons than protons, and so this has an overall negative charge, and we call these ions anions. If we look at our periodic table, we can see that metals lose electrons and they become cations, and non-metals gain electrons and they become anions. And when we look at the periodic table, we know that all elements in group 1 have 1 electron in their valence shell. So when they lose that electron, they become an ion with a charge of +1. Elements in group 2 have 2 electrons in their valence shell, so when they lose their electrons to become an ion, they become a cation with a charge of +2. At the other end, we've got these elements in group 17, the halogens, they gain 1 electron to become anions that have a charge of 1-. These elements here in group 16, they gain 2 electrons when they become an ion, and so they all end up having a charge of 2-. Pretty easy. So here's sodium, Na. Sodium is in group 1. Remember, group 1 elements lose 1 electron, so sodium loses 1 electron and has an overall positive charge, and so we put a plus there, and it is a sodium ion. Chlorine, on the other hand, is in group 17. It gains 1 electron, and therefore it's got an overall charge of 1-, and now we call it chloride. Sodium and chloride, as you can see, have opposite charges. Therefore, as we all know, opposites attract, and so they are attracted to each other, and they form what we call an ionic compound. A really common one that you know very well, sodium chloride. Now, ionic compounds don't exist as just one ion attracted to one other ion, such as sodium and chloride. They actually exist as what we call a 3-dimensional lattice. And so when you have a little grain of salt, in there is millions and millions of sodium ions and chloride ions, and they're all held together in this thing that we call a 3-dimensional lattice. Every sodium ion is surrounded by a whole lot of chloride ions, and every chloride ion is surrounded by a whole lot of sodium ions, and they form this big 3-dimensional lattice, and that's what holds it together. So when we see this formula here, what it's actually telling us is that in my little lump of salt, for every 1 sodium ion, there's 1 chloride ion, and so it's showing us a ratio of sodiums to chlorides. Now, what's going to happen when we get a group 2 element like magnesium? Well, magnesium loses 2 electrons, and therefore it has a charge of 2+ when it becomes an ion. If it gets together with chloride, which only has a charge of 1-, you can see that magnesium has got 2 positive charges, but chloride has only got 1 negative charge. So therefore, even though their charges are opposite, they're not equal. So in a magnesium chloride compound, we need 2 chloride ions to balance the magnesium. And therefore, if I have a piece of magnesium chloride, in that 3-dimensional lattice of magnesium chloride, I'm going to have a ratio of 1 magnesium ion to 2 chloride ions, and so in this case it's a ratio of 1 to 2. How about something tricky like this? Aluminium, when it forms an ion, has a charge of 3+. Oxygen, when it forms an ion, becomes oxide with a charge of 2-. These are opposite charges, but they're not equal. How are we going to make them equal up? Well, what's the common multiple of these two? 3 times 2 is 6. So we're going to need 6 charges altogether. So I need 2 Al3 pluses, which gives me 6 positives, and 3 O2 minuses, which gives me 6 minuses. And so I write it like this, Al2O3, and that's the formula for aluminium oxide. And in this case, the ratio of aluminium ions to oxide ions is 2 to 3. Now, some ions are what we call polyatomic ions. For example, NO3-. This ion we call, anyone know? It's nitrate, and it's got a charge of 1-. Now, if nitrate wants to join up with magnesium, magnesium's got a charge of 2+. How many nitrate ions are we going to need to balance the charge? You guessed it, 2. And so, here's the tricky bit. How do we write it? Mg brackets NO3 brackets 2. That 2 means I've got 2 NO3s and the brackets show that ion is together. If I put Mg NO3 2, that doesn't make sense. Who's going to write that kind of stupid stuff? Are you? Here's one more hard one to try. SO4 2-. This polyatomic ion is called sulfate. Fe3+, this is iron 3. Now, if I've got these two, they're opposite charges, but they're not equal. I need to balance the charges. What is the common multiple of these two? 6. So I need 6 positive charges, so 2 Fe's, and 3 sulfates. And there we go, opposite charges, and now they are balanced. How do I write that? Fe brackets SO4 brackets 3 and a 2 here to show I've got 2 Fe's. So Fe2 SO4 3. Piece of cake. So that's it for today. Just a short one. Sayonara.